So in today's final session for day one of GeekCamp conference, right, we are actually really excited to have Nicolas Frankel. So Nicolas will be sharing with us a little bit on an easy to set up architecture that leverages on what we call the ChangeDataCapture design to have an evergreen cache. Right, so Nicolas is a developer advocate with 15 over years of consulting across many different customers in different industries and different contexts as well. So that ranges across telecoms, banking, insurance, and large retail and even public sector, for example, right? So he also doubles, as far as I understand, as a teacher in universities and also in higher education schools. He's also a trainer and triples up as a book author. Right, so ladies and gentlemen, please welcome Nicolas on stage for next session, a ChangeDataCapture use case, designing an evergreen cache.
Hi, everybody. Well, you already introduced me, so I don't need to tell the rest. I work for a company called Hazelcast. We have two products. The first one is called an in-memory data grid. And basically, you can think about an in-memory data grid as distributed data structures distributed over the network about several nodes, like clusterized. And the other one is called Jet, and basically it leverages in-memory data grid to do in-memory stream processing. Since I will be using both of them in the demo, I won't go any further. Just to let you know that we are very happy to have participated in Google Summer of Codes this summer. And so now it's ended, we had 2 students and it's amazing. So we are committed to open source. So if you are interested in open source solutions, please just check. Okay, so the agenda for today will be first, why are we caching? This is the most important. Why are we caching data? Then we will see some alternative, because one issue is to keep the cache in sync. So what can we do to keep the cache in sync? Then we will focus on a very specific way to do it called ChangeDataCapture that has been promoted in late years, I would say. And in the realm of the Kafka and the Java ecosystem, there is something called Debezium. It is a CDC implementation. Then I will tell a bit about how Hazelcast leverages Debezium. And then finally, I will finish with a demo. So first, you must understand something. If you want your data to be always available, and I'm talking mainly about microservices or databases or whatever, you need to keep your data as close to the provider as possible. And the problem is, well, with database, it's more or less always available. With microservices, not that much. But one of the way to keep the data close is to have caching. So when you first successfully gate the data, then you cache it locally. And then if it's not available, then you serve it from your local node. But very important, it's a trade-off. That means that if you serve the data locally, it means that your data might not reflect what is in your database or your microservice, and so you are serving stale data. But, so I will use a database here. The thing is, if your app is the only component that reads and writes, and more importantly writes to the database, then whatever you do, you can always go through the cache. And by going through the cache, you make sure that every time you read from the database, well, you wrote previously, so basically it's in the cache. And so the cache is not stale, and everybody is happy, and that's what you want. Now, this is, in general, a very ideal view of the real world. In the real world, what happens is you have another component that writes to the database. And in that case, that means that your cache is not in sync anymore. An example would be a batch process that refreshes the database every day, every week, every month, perhaps every hour. I don't know. So you have this table of references, and they are updated every now and then, and now your cache is not in sync. And this begets the question, how to keep the cache in sync? Because I don't want to serve reference data that is stale. So you might know this quote that actually there are two hard things in computer science, naming things and cache invalidation. And of course, the joke is to add off by one errors. So there are two ways to manage that. And first, I need to define the difference in terms, because I've sometimes seen people that get confused. The first thing is cache eviction. And you do cache eviction when your cache is full. So basically, a cache needs to be limited inside. It cannot grow unbounded. Otherwise, it will take all the memory and your application won't have any memory anymore. So always a cache needs to be bounded. And what happens when your cache reaches the limit and you want to add more entities? Well, you need to remove previous entities. And in that case, you have cache eviction. And in general, if you are using a professional solution, the cache eviction strategy is configurable. So you can have the least recently used, the least frequently used. You can have your own, perhaps adding a priority or whatever. So this is cache eviction, and it has nothing to do with the time to live. Time to live means when you put a data into the cache, then you say, oh, I will keep it into the cache for some length of time, for some duration. Now, what is the correct TTL? Because remember, one of the hard things is cache invalidation. And the correct TTL must be the frequency at which the backend is refreshed. If you basically have a TTL that is less than the update frequency, which is less frequent, so which is more. So imagine you have an hourly batch that refreshes your table, and then you say, oh, my cache will be, when I put an entity, I will keep it for 2 hours. That means that during 1 hour, you will have new data coming in, and the cache won't be good. It will be stale data. Now, if you say, my time to live will be 30 minutes, or perhaps 1 minute, that means that if you know that your frequency is 2 hours, and you will be removing, the entity from the cache, so we will need to check again from the database every minute, and it will be a waste of resources. So it's easy. You just need to know at which frequency your backend is refreshed. But it needs to be very precise. And the problem is with batches, you have more or less an idea of the frequency. You say every 2 hours, hourly, or whatever. But in most cases, it can be completely random. You have no clue. And so what can you do? Well, you can poll. So every now and then you can check, hey, do I have new data? Do I have new data? But then you get back to the same problem as before. You don't know about the frequency, and the polling process needs to have a frequency. So you say, hey, I will check every 2 hours, every minute. So it's the same issue. So if you have been doing some event-driven programming, you know that the solution for this problem is event-driven. And event-driven means that when the database is refreshed, you are informed about it and you do something. And the good thing about it is if no writes happen, then you don't do anything. And as soon as a write happens, then you update it. How do you manage that? Event-driven for databases? That seems a bit strange. Well, if you have been doing database a long time, you know that there are such things as triggers. Now there is an issue about triggers is first, not every database implements triggers. And the second issue is triggers are very, very good if you stay within the database itself. Now, if you need to do something that goes out of the database, like updating a cache, how can you call this external process from a trigger? So I've checked a bit. And for example, yes, you can do it within MySQL. So first, MySQL has triggers, which is good. And then the process goes like this. First, you must write your function in C++. the operating system has to support dynamic loading of libraries. And now your function becomes part of the running server. And so this is not trivial, and it is a bit fragile. This is how it goes if you want to have it in a, like, say, easier way. There is a GitHub project that does it for you. So basically, it creates this bridge between the trigger and the external process that you need to call. So you only need to actually have these commands executed. You need to write just this command, and then it's done for you, which is a bit better already. Still, it's very implementation dependent. It's fragile, so if it breaks, okay. And yeah, if it breaks, who will maintain or debug it? This is port development. This is port database management system. This is port ops. It's going to be a nightmare regarding the organization. And if you are familiar with triggers, you know that it's especially resource consuming. If you have a lot of triggers, and for a long time, when I worked for companies that were having database that were trigger friendly, basically we had advices not to use triggers at all because it's very resource consuming. Okay. And perhaps you have heard about this thing called ChangeDataCapture. And this ChangeDataCapture is actually quite old, but it has been renewed right now. And basically it's just that, is like, if you do a change on the state of a database, then you transform it into an event. And there are several implementation options. As I mentioned, some of them are quite old. And as you can see, the first three are based on polling. So basically you add an additional column, and every time you poll, you check that the latest timestamp is passed, and that means there has been a change, and then you check the change. You can do the same with version numbers or like specific state indicators, but basically, again, it's based on polling. And as mentioned, polling is not the right way to do it because there might be a mismatch between the polling frequency and the refresh data frequency on the database. The fourth solution is triggers, same stuff, it's very fragile. And the fifth is quite interesting, it's log scanners. So let's dive into that. You might have listened or read this blog post about Martin Kleppmann. Martin Kleppmann is a very interesting guy in this database scope, and basically is very interested. He talks about distributed systems and how you can use like databases and even streaming and this kind of stuff. And in this article, he talks about a traditional database, and a traditional database, actually, when I mean traditional, I mean SQL databases. They are mainly SQL databases, and they are in a master-slave clustering, or leader follower, if you prefer that term. And basically that means that there is only one leader at any one time. And if you want to have like a failover, you have this follower, and the follower needs to be in the same state as the leader. And for that, there is something that is an implementation detail. So eventually, the follower will be in the same state as the leader. It's eventual consistency. And so when the leader fails, the follower will like keep up the changes, and then it will be elected the leader. And this implementation detail in most databases, in most SQL databases, is just a log file. And when I say a log file, it is basically all the changes that have happened to the state of the database. And for example, in MySQL, it's called a bin log. In other databases, it has different names, but basically it's the same. So as I mentioned, it can be used for replication. It can also be used for data recovery. So in case the leader fails and there is a crash, then it needs to reread the changes, and it reads the changes from this log. So what we could do is we could hack the log, and then we could actually like transform the changes into events and react upon those events. And this is a MySQL bin log. And as you can see, you can read some of it, updates, whatever, where, blah, blah, blah. And you have a lot of crafts around it. So it's basically, it's like very hard. It's very cryptic to understand. You need to understand what is relevant, what is not relevant, and it depends on the database. So for example, the MySQL bin log is different from the MariaDB bin log, and the MariaDB is just a recent fork from MySQL. So implementation dependent, fragile, and who maintains and debugs it. So I don't want to deal with that myself. Unfortunately, there is something called Debezium, and Debezium does that for us. So it presents an abstraction layer for CDC. It's provided by Red Hat and it's open source. And it's very good for that. So basically, I just need to use the Debezium API, the Debezium model, and Debezium will care about the different databases. Now there is an issue, is it's quite skewed toward Kafka. So basically, I will show you the architecture, but basically, you should use Kafka. And as I mentioned, it's an abstraction. So it's like for JDBC, you have an API, and then you have different implementation that you can plug. So here you can see there is a production-ready connector for MySQL, for Postgres. There is one incubating for Oracle, whatever. And normally that's the standard use case. You have Kafka deployed, and then you have connectors. And then you have a connector for each database, and every time there is a change in MySQL, so you have configured the connector, it will read the bin log and it will write the events into a Kafka topic. Seems pretty good if you are using Kafka. But let's suppose that you are not interested in persisting those records and you want to be very, very fast. So Kafka means you need to write to disk. And so we have this thing called Hazelcast Jet, which is a stream processing engine. As I mentioned, is completely open source. It's in memory and it's distributed all over the network. We also have an enterprise offering, but that's something else. And basically what it does is it reads from a source. It does some changes, filtering, whatever, aggregation if you need to, and it writes into something else. And for example, we could decide that it reads from CDC events and it could write it into a cache, in-memory cache, just such as IMDG. There are two deployment modes. Because it's written in Java, the first deployment mode is you deploy it inside your node along your application. And in that case, they will cluster, they will form a cluster, they will broadcast over the network and form a cluster, which is good. This is very easy to start with, but we also have a client-server mode. And here you don't need to have a Java application. We have a binding or a client API for C#, for C++, for Go, for Python, and for Node.js. And then you can deploy your nodes, your application nodes, and your EMDG nodes independently. It's based on the concept. Those are general streaming concepts, but here the name is a pipeline. So basically, pipeline is declarative code, and then you send this pipeline to the stream processing engine, and it becomes a job, and it's the Jet's job actually to distribute it all over the network. So getting back to our use case, what we can do is we can deploy a Jet job that will read the bin log from the database, and every time there is a change, it will refresh the cache. So now you have this component that is writing, we don't care about it, it will be captured in this bin log, and the cache will be refreshed every time. So now I have a couple of time for a demo. Sorry, up. I have a bit of time for a demo. I have this application, and I perhaps don't go into the detail. What is important is I have this Docker Compose file, which is composed of my application. So it uses the cache. It has this jet pipeline that I will remove it because I don't want, I want to show it how it doesn't work. And I have the database. So I will start the application, and it takes a bit of time because I need to create all the components. I need to create the network. At some point, it should tell me that everything is fine, and I need to stop the pipeline because, again, I want to show you that at the beginning, stop pipeline. So here, I just have the application, the database, and the cache in between. And how it works, I refresh everything. So I have this like initial data, and here I update it. It does a refresh, and it reads from the cache. And it can work here as well. So here, since my application is the entry point into the writes and into the reads, the cache is always synchronized. I'm very, very happy. Now I will do something bad. I have an application. I have a command line application that allows me to change the database. So here I can list all the entities. You can see this is the existing state. And now I will have a change. So here I will say that the first line here, now it will be Robert. So it will be Robert do. And now if I list it again, and here I'm reading from the database directly, I don't go through the cache, there is Robert. But my application is stupid. My application just reads from the cache. And so I still see Johnny here, which is not what I want. So what I'm doing is I will start this pipeline, the jet pipeline. And this jet pipeline, as I mentioned, will read from the bin log, and it will send the changes as events. And then I can react upon those events. Again, takes a bit of time to start. And the good thing here is it will read the events, it will read the changes from the bin log that were previously written there before it started. So the change from Johnny to Robert is in the bin log, and it will read from there. Takes a bit of time. It should tell me that everything is fine at some point. Let's try it. No, it's not ready yet. Let's try. Yes, it's here. And as you can see now, it got the change. And now if I, of course, if I do more changes now let's say I update the second row to Clara. It's in the cache. And that's very cool. So now I have an evergreen cache. My cache is always in sync, and I don't need to concern myself with these out of sync things. So in this talk, I've presented you about the caching trade-off. You've got data that is always available, but might be stale. So that's a real issue. And if you want to have a data that is always available, but not stale, you cannot do polling. You need to be event-based. And in order to be event-based, you can leverage Hazelcast Jet to have ChangeDataCapture on your database so that your cache is always in sync. So, sorry, I hope you like this talk. You can read my blog. You can follow me on Twitter. You can read the tutorial about jets. And of course, you can get the repo because everything is on GitHub for this demonstration. So you can do it at home. And perhaps there is some questions now.
Yep, I'm just looking at the question and answer list here, and I don't seem to see any questions that's come in actually for you, Nicholas. Let me just
So
take a
it can mean it was a very good talk and everything was clear, or it can mean it was a very bad talk and it was so bad that nobody dares to put me in a bad situation by asking questions. I never know.
No worries, yeah. But yeah, in any case, it was really, really great. Like, I love the demos. I was really excited to see, like how the change data capture design can be also leveraged to have an evergreen cache. So thanks for the great talk and demo as well.
I've got questions.
Awesome.
I've got questions. So I have a new question, and thanks for the question, Ambrose. So is it scalable horizontally? Yeah, as I mentioned, so everything is clustered. So Jet basically forms a cluster. Here, of course, in this 2P demo, I only have one node, but you can have as many nodes as you want. And then Jet will distribute the load over all the nodes. So yes, by design, it's scalable horizontally.
Yep, I think there's one more question that came in for you, Nicholas. Like, the question is, is there any benchmark on the performance impact on the database server?
That's a good question. And for CDC itself, there is no performance impact at all. The performance impact comes from writing into the bin log, because here you will actually, you cannot do asynchronous writing. You need to write synchronously so that you make sure that all your changes are in the log, because if your changes are not in the log and there is a crash, then they will be just lost. So the performance impact comes from this bin log, but I assume that you already have it because you want your changes to be kept there and because you have a master slave or leader follower architecture. So if you already have this bin log, the impact is 0. If you have not this bin log, then your architecture is already a bit fragile, and you can say that it's about 10%. I mean, but it probably depends on the exact database implementation.
Awesome. Thank you so much, Nicholas. That was a great session, and I really enjoyed it. I believe the same for the rest of the audience as well.